Good morning, everyone. Thank you for being here. We are excited to present our project titled Ransomware Detection and Mitigation System, a simulated implementation for this course. I am Magapu Abhay, and I am with my team members Ashok and Shiva. Abhay. To begin, our project simulates a ransomware attack using a hybrid encryption method. Fernet for the file encryption and RSA for securing the Fernet key. The attack is delivered through a phishing style executable mimicking real world infection vectors. We monitor file system activities using Python's Watchdog library to detect rapid file changes. Once suspicious behavior is flagged, the system issues alerts, terminates the malicious process, and proposes recovery options. Overall, this project emphasizes a defense in-depth approach. Problem statement and our motivation. The core problem is the growing threat of ransomware, which causes both financial damage and data loss. Many attacks go undetected until the damage is irreversible. With ransomware becoming more sophisticated, real-time detection and quick response mechanisms are more important than ever. Our project goal. Our goal were fourfold. First, to simulate the full ransomware life cycle from infection to encryption. And the second one, to monitor file systems in real time. And third one is to build in alerting and mitigation mechanism. And finally, to offer an educational blueprint for detection and defense can be structured in layer systems. And my team, Ashok, will continue from here.
Yeah, hi. This is related work. This is on first one we have a real-time anomaly detection. We use this for influence or monitoring and detection. And second one, Karas Ethel AI. This we use this for both Fernet and RSA. And third one, Natraj at L. This is for threshold-based file monitoring. And last, we're gonna look for WannaCry ransomware, studied by Semantic, which helped us to understand real-world ransomware behaviors like dropping ransom notes and encryption large file sets. And coming to the next slide, in system architecture, we have four modules. For encryption, we use the Python cryptograph library with Fernet for symmetric files and encryption, and RSA for securing the key. And second one, infection simulation. We use for compile our ransomware script into windows.exe using PyInstaller and Microsoft Verifier.exe. And third one, monitoring. We use for Watchdog library to track file system activity in real time. And fourth one, mitigation. Once suspicious activity is detected, the system uses Pistol to kill the ransomware process and alert the user. And we use the tools like Python, PyInstaller, cryptography, Watchdog, Pistol. And coming to the next slide, encryption and infection simulation. In our encryption process, the ransomware scans directories and encrypts each file using the Fernet, which is fast and secure. The Fernet key is encrypted using the attacker's RSA public key. This means only the attacker with the private key can decrypt these files like in real ransomware. The .exe file that initiates this behavior is discussed as Windows process and shared by phishing style email or message. Simulates how ransomware spread in real world scenarios. Coming to the next slide. Monitoring and detection. We implemented a lightweight monitoring system using a watchdog library. It tracks key file and events like creation, modification, and deletion. Our detection rule is it's simple. It's more like 5 files modification occurs within 10 seconds. The behavior is flagged as suspicious. This rule balances and speed. All events are logged in CSV file and tracer reviews this log to identify any pattern that meets our detection criteria. Once a threat is detection, the mitigation module terminates the malicious process and stop the future damage. And next part explained by Shiva.
Yeah, hi everyone. Now I'm going to talk about the mitigation strategy that we deployed. So basically, as Ashok previously explained, we wrote down some rules according to which an alert is triggered. We used Python's tkinter library in order to create Windows graphical user interfaces. We have some pop-up alert pop-ups asking for the user if the changes that have been made are legit, and if he or she says it's I mean it's yes, uh, in that case nothing would happen. Otherwise, we tend to send an email to the security team, and also we create a backup files every time. As we told that we have proposed some uh, backup methods where every 30 minutes a new backup for critical directory is being created. And we also proposed some useful guidelines in that organizations can enforce on their employees. Now let's have a quick demo where I'll show you our process. Uh, Abhay, could you stop sharing your screen? Thank you. Uh, First, as we previously told, we have an exe file which has been sent to victims desktop as a disguised as Microsoft verifier.exe. Where as soon as we run this, uh, it's gonna take like maybe 3 seconds. The documents are not, won't be able to be accessed. And see, we cannot open this file. Uh, Meanwhile, as we previously mentioned, our anomaly detection script is active, which is asking if the multiple files are changed at once, do you flag this as suspension? We'll say it is not, it's a trusted changes. Okay. Then, as we can see, we have a secret key, but this is encrypted using RSA key, so there would be no way we can use that key. And as we can see, at 6:39, we have a modified notification in the detection log.csv. Also, we also have this backups, which it is triggered every 30 minutes. So in this, we have the readable format. So with the redundancy, we are able to achieve this safety. Uh, yeah, that's it from our flow. I gave a high level flow regarding this. Thank you. Uh, Abhay, could you start sharing the slides again, please? With this, we are able to successfully encrypt and decrypt. Once the ransomware is sent, the decryption is done, and we are using monitoring script in order to log all the changes that have been made. And as part of detection script, we have defined some rules according to which an alert is triggered, and when we click no, an email is sent, and the PC gets locked down. Can we go back? I want to show the how our system logs down once the flag it is flagged as suspicious. Can I start sharing my screen?
Yeah. You can start sharing.
Uh, Now I'll try to maybe like delete all at once, which should also trigger it. Or maybe I'll just run the script over again. So once I'll say that it's not the admin is notified, an email is sent, and also we are logged from, all the processes are killed and we are logged out from our desktop. That's it. Could you share your screen? So as we have showed everything like how defense in depth works and how usage of backups will save us from such attacks, that's it. That would be from our side.
Thank you.